Welcome back to the AITEC podcast. Today I'm sharing a conversation with Iwan Williams. Iwan is a philosopher of mind, artificial intelligence, and a researcher at the University of Copenhagen. Specifically, he's working at the Center for Philosophy of Artificial Intelligence. He earned his PhD at Monash University, and in this episode, we are going to discuss his article, Intention-like Representations in Language Models, ? And so, the central question we explore is, whether large language models exhibit anything that genuinely resembles intentions, or whether such descriptions, describing a model as having a certain intention, whether such descriptions are ultimately just metaphor. All right, I hope you enjoy the conversation.
Just to get started, maybe could you just briefly introduce yourself, maybe, where you're from and kind of how you got interested in philosophy?
Sure. So I'm originally from Wales in the UK, and I suppose I kind of stumbled into philosophy in a way. I was always into kind of big, deep questions, navel gazing, you might say. But and then, when it came to choosing a university degree, I landed on philosophy, not knowing all too much about it, and ended up loving it, and have pursued it since then into graduate studies. I did my PhD in Monash in Australia, in Melbourne, and I've now made my way back to Europe. I'm now in Copenhagen doing a postdoc, and my kind of interests began mainly in philosophy of mind and philosophy of cognitive science, but in the last couple of years I've been thinking about AI, like a lot of people, like yourself. So that's kind of where my intellectual interest is at the moment.
Awesome. Yeah. And so basically in this particular paper that we're going to be discussing, you're sort of dealing with the question of hey, do these large language models, do they have mental states? Specifically, you're thinking about a specific kind of mental state, the mental state of an intention, rather than a belief, let's say. So cool. So before we kind of get more into that, maybe just to get us oriented, we could just start with a really simple question, just to remind listeners kind of, what is a large language model?
Of course. So most people will have encountered large language models indirectly, if they've not come across that term. These are the core technologies underlying chatbots like ChatGPT and Claude and Gemini. And what they are is machine learning models. They're a particular type of machine learning model. So they're models that are designed with the goal of predicting or processing or generating language or text, as opposed to some other type of model that might be dealing with images or different kinds of data. And under the hood, these are artificial neural networks. So they're so-called because they're very, very loosely inspired by the structure of brains, of neurons in the brain. And in particular, these large language models are often using a transformer architecture as a particular type of neural network, that the details of which we don't need to get into here. But the way these systems work at a kind of basic level is information is processed through these networks in a way that's determined by a bunch of mathematical operations. And these aren't, it's always worth kind of emphasizing this, not everybody is aware of this, these aren't hand-coded by engineers. Engineers aren't kind of fixing the minute details of how exactly a language model works. Rather, as the name machine learning implies, they're kind of learning or emerging certain solutions to problems, in this case, predicting and generating text, by being trained on huge amounts of data and using some sophisticated learning algorithms. So often in the case of language models, that might be feeding the model a huge corpus, like a bunch of text taken from the internet, and then using a kind of next token prediction task where a model is kind of updated based on its ability to guess the next word in a string of words. And what you get if you do this millions or billions of times using the right kind of architecture is a model that's quite impressive at mimicking the kinds of responses that a human might give in response to some text inputs. So it's kind of useful or, broadly factually correct answers to text-based questions or requests. What's less clear, and we'll get into that a little bit today, is exactly how they do that in terms that are actually comprehensible to us. We can talk about the specific kind of matrix multiplications that go on inside a system, but that doesn't actually tell us all that much about how the model is solving some particular task or problem.
Yeah, and it's interesting that it's so successful at imitating our kind of linguistic abilities that that it makes you wonder, is it kind of doing it in a similar way that we're doing it? But so one kind of question, maybe one kind of philosophical question one might want to ask with respect to language models is, do they have mental states? So yeah, could you kind of introduce us to that type of question?
Yeah, of course. So mental states is somewhat of a term of art that philosophers use, but it's fairly self-explanatory. We're just talking about states that arise in our mind. So that could be beliefs or desires or perhaps perceptual experiences or pain or bodily experiences, emotions, and so on. So there's a whole kind of zoo of different types of mental states that philosophers are interested in for different reasons. And we might talk about, we might think of some of those having a distinctive experiential aspect, some kind of conscious phenomenology or conscious character that goes along with something like the experience of pain. But there's also kind of aspects of the causal role or functional role of different mental states. So something like a belief might be more characterized in terms of the kinds of states or conditions that trigger a certain belief, or the kinds of effects on behavior that having a certain belief generates. And yeah, so that's what we mean by mental states. The question about language models, as you point out, is if they're so sophisticated in terms of their behavior, in terms of their ability to kind of, as you say, mimic the linguistic capacities of humans, there's a question of whether they're doing it in something like the way that we are, which would be in a way that's mediated by mental states, like beliefs and desires and intentions.
Great. Yeah. So it's really important to think about that distinction you made in terms of like, you can take a mental state and describe it in terms of its phenomenology, but then you could also describe it in terms of its causal role. So like, there's a phenomenological description you could give related to intending to like drink coffee, let's say, you might have an urge toward the mug, the thought of drinking coffee, it's like something that makes you feel like it's something to be done. Whereas the causal role description, you might talk about how insofar as I have an intention to drink coffee, that's going to increase the probability that I reach for the mug or not do something else, suppress other competing options for action. So anyway, just important, I think, to highlight that distinction between a causal role description of a mental state and then a phenomenological description.
Yep, for sure.
Great. So, people might find it interesting that, I think among researchers, like, I guess, philosophers, for example, many think that you can say that large language models have something like beliefs and credences. So, could you kind of explain that line of reasoning? Why think a large language model has something like a belief or a credence?
So we should maybe be a little cautious in exactly how widely subscribed a view like this is. I think there would be many people who'd would not sign up to this idea that language models have beliefs and credences. But certainly when we look at kind of AI research, researchers are very comfortable with talking about knowledge states in language models, and occasionally beliefs as well, using that term explicitly. And there is a question of whether this is just a kind of loose talk, a kind of metaphorical way of speaking, what ChatGPT is thinking about or what it knows about the world. But I think there's some reason to take it somewhat seriously. I mean, if just at the behavioral level, if we look at how a language model might respond different kinds of fact-based questions, we might be able to elicit answers from ChatGPT that look like it has the belief that Paris is the capital of France, for instance. We could ask about that particular fact in lots of different ways and get answers that are broadly consistent with what you would expect somebody to say if they had that particular belief. But maybe kind of slightly more compelling evidence is when we look under the hood in these language models. There's been kind of a line of research trying to uncover something like belief states internal to the workings of language models. And what we find, or one line of evidence, is the states that are induced by false statements, or more carefully, false statements which the model is likely to respond to as false. Those kind of internal states look very different from the internal states that are induced by true statements. So they almost seem to cluster in different subspaces within the kind of internal encoding scheme of the model. And more than that, not only are we able to kind of, from the outside, distinguish these two different kinds of internal states, that seems to play a causal role in their responding to sentences as true or false. So we can actually intervene on these internal states and make it start responding as if it believes that Paris isn't the capital of France, by kind of pushing that internal representation towards the kind of false subspace and moving it more in that direction. So, some have drawn the inference that, well, this is acting in something like the way that a belief is in human psychology, that it's some kind of internal state that's encoding something about the truth or falsity of some statement or some fact in the world. But there's been a bit of back and forth about whether that's enough to count as a belief and so on. But certainly beliefs and credences are the sorts of things that do get talked about a bit more than something like intentions, which is partly what inspired this line of research.
Awesome. Great. That's really helpful. So your line of research that we want to talk about, is really specifically about intentions. So you just kind of reviewed a little bit, the line of reasoning for thinking that language models have either beliefs full blown or maybe something approximating it. Could you kind of introduce us to your question of, do language models possess intentions?
Yeah, I'd be happy to. So maybe it's worth just first kind of distinguishing beliefs from intentions in a kind of coarse-grained way. So beliefs are mental states that try to, in some way, track the way the world is. We're trying to kind of get an accurate picture of reality by forming beliefs that correspond with that reality, that encode contents that are true about the world. Intentions, by the other hand, they kind of sit on the other side of the process of decision making and reasoning and acting in the world. They're more closely tied to the action side of things. So intentions, you might think of them in terms of decisions or plans about what to do, that driving or motivating action in a more direct way. So if I have a belief that there's beer in the fridge, that's quite different from having an intention to put beer in the fridge. Right? There may be no beer in the fridge right now, but if I have that intention, then it's going to alter my behavior in such a way that I make that goal state become true, or at least if I'm successful in executing the intention. So that's one kind of way of thinking about, at a basic level, how intentions differ from beliefs. And when it comes to language models, whether or not we think language models have something like belief states or something like belief states, we might also wonder whether these systems have something like intentions. Do they form plans? Do they represent the actions or things that they're about to do before they do them in a way that's kind of guiding or controlling their behavior? So that's the question. And there's a number of reasons why you might be interested in a question like that, which maybe we can get into in a moment. But that's the question.
Great. Yeah. And just so, I don't know, just be clear, maybe, would you say that you're looking into whether language models contain, internal features that strongly resemble the kind of functional causal role that intentions have? Or, in your mind, are you just full blown trying to figure out whether language models have genuine intentions? Like, are we looking for something that's intention-like, or just a genuine intention, I guess? Does that make sense?
It does. And it's a very good question. I mean, I hedge in the title of my article. I say intention-like representations in language models. As you say, question mark, right? I'm interested in that question, but I suppose I am first and foremost interested in the question of whether they have intentions. And I think that's kind of what starts the debate. People are interested in, should we ascribe this mental state that we ascribe to other human beings and maybe non-human animals? Should we ascribe that to these cutting-edge AI systems? But in a sense, I think where I end up is thinking that maybe that's not an entirely well-formed question, or to put it another way, it might not be the kind of question that we can get a clean yes or no answer to. So it might be that intentions as mental states are kind of characterized by a cluster of different features, and maybe those features can be present to a greater or lesser extent, and we might find states in language models, or for that matter, non-human animals or other situations, where some of those features or some of those criteria are met and others aren't met. And I want to be a little open-minded about what we should do in a situation like that, whether we should say, okay, just categorically they don't have intentions, or whether, a more honest or answer is something like, well, they have states that are intention-like in many interesting respects, but not in other interesting respects. And that might be actually more informative than just trying to squeeze it into a binary distinction.
Yeah, it also seems like, I'm not sure if this makes sense, but it seems like the proper order of investigation would be, you first try to establish to what degree the two things resemble each other. You kind of take various factors that you find in human intentions, see how much the language models, various, representations within the language model resemble those, and then you kind of work up to the question of, okay, so given the resemblances, does that ultimately count as, instantiating a full-blown intention? So anyway, it just seems like this is kind of the proper order, if that makes sense. But at this point, maybe we can, go back to something you mentioned earlier, which is like, the whole importance of the question, of asking, whether language models have intention-like representations. So yeah, would you like to address that? I mean, you talk a little bit about communication. You mentioned things related to safety concerns. Anyway, yeah, do you just want to briefly touch on why this is kind of a pressing question?
Yeah, of course. You might be interested in the question for various different reasons, and I think intentions get invoked in different contexts, often without kind of serious engagement about the question of whether they do have intentions or not, or at least not very much evidence is presented. Sometimes people just categorically deny it, or sometimes they just assume that AI systems do, or in the near future will have intentions. But this gets invoked in various different contexts. So one context might be interested in questions about communicative capacities, the ability of these systems to engage in the kind of communication that we human beings do with each other. So just for example, when humans use language, we don't just kind of generate words or tokens for the sake of it. We're engaged in some kind of communicative project with some other human being, typically. And one kind of aspect of that is what's been referred to in philosophy of language as speech acts. So we might, for example, make an assertion to another person, which is, trying to kind of communicate our belief in that claim, and perhaps even to make the other person believe what we believe. Or we might give a recommendation or a command to somebody, or a suggestion, try and change their behavior through our use of language. Or we might ask them a question to try and kind of elicit some information from them. So these are different things that we do with words that we use language for. And it's very common on kind of in theorizing about these different kinds of speech acts, to require some kind of intention behind the language, that merely producing or generating the language isn't enough to have performed one of these speech acts. In the case of assertion, a kind of traditional picture would hold that you need to have an intention to induce a belief in the hearer or in the audience, whereas or more generally, you might just think that you need an intention to make an assertion, right? To actually be making an assertion. So that's one kind of motivation for the question, is you might think, do language models perform speech acts, communicate in the way that we do? That might be partly dependent on questions about intentions. A quite different motivation might be questions around safety. And I'm a little open-minded about exactly how relevant ultimately this question about intentions is going to be to kind of practical questions about safety. But certainly some people in this AI safety research community who are interested in analyzing and predicting and preventing certain harms caused by the use of AI technologies, one thing that they're sometimes worried about is so-called runaway or deceptive AI. It's kind of getting towards slightly more speculative and long-term kind of concerns, but people are genuinely worried, or many people are genuinely worried, that we'll soon, if not already, be faced with AI systems that have intentions that are in conflict with our own best interests. And not only that those intentions might be hidden in some way, that they might be strategically or otherwise masked by the model's behavior, that they're not kind of superficially revealing their misaligned intentions. So intentions get invoked in that debate as well. This idea of misaligned intentions, but again, we should care, really, if that is a real concern, we should care about whether we already have systems that have intentions or have something like intentions. And perhaps this might be relevant in some ways in then some point down the line, identifying and monitoring these intentions for safety purposes.
Great, that's really helpful. So we kind of have on the table, sense of the question that we're going to, you're asking here, the research question, do these language models have something like intentions? And then we have a sense for, the importance of this kind of question. It seems like intention, for example, is kind of essential to communication. Now, maybe let's talk about, what's your method for approaching this question? It seems like, correct me if I'm wrong, but it seems like your approach is first let's propose 5 properties, 5 qualities that are typically associated with intentions that seem to be really important for a human mental state to be an intention. And then we kind of look back to see if there's any representations in large language models which possess all 5 of those properties. Is that kind of how you would describe your method?
Yeah. That's exactly right.
Okay, great. And and just to be clear, you're not saying these 5 characteristics, which we'll talk about in a second, are the consensus definition. So some people might be uneasy about saying these 5 properties are define an intention, but at any rate, they do seem to be typically associated with intentions. So maybe we can just start talking about some of these 5 marks, you might say. So the first one you bring up is directive function. Can you kind of tell us a little bit about this first characteristic?
Yeah, of course. So directive function, we've touched on it a little bit already to some extent when we talked about this distinction between beliefs and intentions. So beliefs, as I mentioned before, are in the business of trying to track the way the world already is. So you might say that beliefs have what's sometimes called a descriptive function. They're trying to kind of describe the actual facts of the matter. intentions, by contrast, have what's some people call a directive function. So they're trying to direct the behavior of the containing system, right? The organism or the human being that has the intention to make some changes in the world in order to attain some goal state. And as I mentioned with this beer in the fridge example, you might have more or less the same kind of state of affairs, or the same content, the same proposition that's targeted by different kinds of attitudes, or in this case, a belief attitude or an intention attitude, where one of the crucial differences is this direction of fit. So in the case of believing that there's beer in the fridge, it's the job of the belief to fit the facts of the matter, to fit the world, to try and get an accurate picture of the way the fridge is right now.
Like, I should only believe that there's beers in the fridge if the world is such that there are indeed some beers in the fridge, right? Like, I should drop the belief if there's no beers in the fridge.
Precisely. Yeah, exactly. Whereas the opposite is true, or it's a very different situation with an intention. It would be weird to intend there to be, or to put beers in the fridge if there are already sufficient number of beers in the fridge. Whereas normally what we would do is we observe that, or we believe that there are no beers in the fridge, and then we intend to change that fact. So the intention has an opposite direction of fit. You might say it's the job of the fridge, or the job of the world, to be brought into accordance with the content of the intention.
And that's kind of like there's like a causal element with intention where, it might initiate a bunch of activity on my behalf to make it the case that the world fits this state of affairs.
Exactly.
Of there being this wonderful state of affairs of there being beers in my fridge.
Yes. Yeah, that's right. Yeah, so that gets at this distinction between directive and descriptive representations, with intentions falling on the directive side of that dichotomy.
Excellent. Okay, so and, we might not have to go. We kind of, I think, for our conversation, maybe we can kind of move a little bit quickly over these 5 marks, and then we can kind of get more into your really fascinating analysis of, okay, given these 5 marks, are there any representations in language models that have satisfy these 5 marks? So we'll come back to the whole directive function idea. But we can move to the next mark. Okay, so the second characteristic you bring up, again, these are characteristics that are typical of intentions, and it's distality. So can you tell us a little bit about this second mark?
Sure. Yeah. So when we think about intentions in our lives, some of them are very closely related in time to the actions that they end up triggering. So, I might form an intention to click my fingers, and then very soon after, in time, I click my fingers. So that's what researchers sometimes call a proximal intention. But other intentions have much longer time horizons associated with them. So if you think about an intention to retire when you're in your 60s or 70s, and you might have an intention to do something next summer, and that's might be shaping your behavior, and certainly shaping your decision making, which we'll talk about a little bit later. But it has a much wider distance in time from the execution of the intention. So this is kind of characteristic of human intentions, that they can span this wide range between very proximal to very distal intentions. And sometimes people talk about a hierarchy of distal intentions interacting with proximal intentions. So this, again, would certainly be relevant if we're thinking about categorizing or assessing representations in artificial systems in terms of how similar they are to intentions. We would want to know, do we find directive representations, that's the first feature, that exhibit something like degrees of distality? Do we only ever find states that are very proximally related in time to the actions that they trigger, or do we find these longer time horizons as well? That would be more similar to a system that has intentions.
Yeah, and that's a good point too about like bringing up the issue of like human versus other animal intentions. So yeah, maybe it's like for other animals, potentially that certain animals only have more proximal intentions related to the next 5 minutes, let's say. Whereas, like you said, yeah, we have kind of this amazing ability, if you think about it, to have intentions that are really far off. Anyway, so it's interesting to think about that. But yeah, great. So that second characteristic is kind of a spectrum related characteristic. It's like an intention can be can be related to the more distant future versus something more nearby in time. And then the third characteristic is related to abstraction, and this is also another kind of like spectrum characteristic. Intentions can be more or less abstract. So, yeah, can you tell us a little bit about this third characteristic?
Yeah, that's right. So, abstraction is less about distance in time, but more to do with how specific or fine-grained or detailed the content of the intention is. So, again, we can have very specific and detailed intentions. So imagine a dancer performing some choreographed dance. They might have very precise intentions about exactly how they're going to move their body in relation to some music or what have you. But many of our intentions are not that specific, not that detailed. So we might just have an intention to get a well-paying job. Right, that intention leaves lots of things unspecified, and there's many different ways one could satisfy that intention. Right, there's a question about exactly what kind of job you get, exactly what qualifies as well-paying, exactly when you're going to execute this plan, and that's not to mention all the possible sequences of bodily movements you could enact to ultimately end up with satisfying that intention. So what this gives a sense of is we can form intentions that are very specific, very concrete, very detailed, and we can form intentions that are much less fleshed out and are much more abstract. So again, this might be something that we consider when assessing candidates for intentions in other kinds of systems, in non-human animals or in AI systems. Are they alike? Are they like our intentions in exhibiting this spectrum of degrees of abstraction?
Great. Okay, so then moving on to a fourth characteristic, which I feel like is really one of the more important characteristics in your paper, which is commitment. And maybe correct me if I'm wrong, but this particular characteristic, commitment, is maybe the one where large language models do the worst on, potentially. I don't know if that's the way you would put it, but anyway, yeah. So a fourth characteristic of intention is that they typically include a factor of commitment. So so do you want to introduce us to that a little bit?
Yeah, of course. So commitment is a bit of an umbrella term. It's capturing a cluster of related features, but two of them that get discussed in the literature on intentions are the idea of, firstly, intentions are conduct controlling. They're more directly linked to the actual production of actions compared with something like desires. So a desire might also be seen as a kind of directive representation, in that it's aimed about it's aimed towards changing the world or motivating us in different ways. It's not necessarily aimed at capturing the way the world already is. But unlike desires, intentions, desires can pull us in all sorts of different directions. So we might have a desire to eat a chocolate cake, but at the same time have a desire to, be healthy and lose some weight or whatever. And whereas intentions are supposed to settle among these inconsistent or desires that are in tension with each other, they're supposed to elect one particular course of action among a range of alternative inconsistent possibilities. So if I intend to eat the chocolate cake, that's quite different from merely desiring to, because I've now kind of chosen that course of action and kind of making steps towards pursuing it. And there's a consequence of this, which is that intentions we tend to form relatively consistent sets of intentions at any given time. So whereas beliefs might pull us in different directions, it would be very strange, or something would have gone terribly wrong in terms of your kind of rationality if you intended to meet a friend for lunch, but at the very same time intended to leave town for the day and get on a plane somewhere. So intentions should, generally speaking, be mutually consistent with each other. There's a slightly different aspect of or different sense of commitment that sometimes gets invoked as well, which is more about stability over time. So when we commit to a course of action, when we form an intention, we tend to stay on that path unless there's some good reason to kind of reopen the question for consideration. Generally speaking, we don't just arbitrarily drop our intentions or reconsider them without good reason. So sometimes people say that intentions are resistant to reconsideration, and that all things being equal, they have some kind of inertia to them once we're kind of set on a path of intending something. So those are kind of two aspects of commitment that might be interesting when assessing intentions in language models.
Great. Okay. And then finally, the fifth characteristic you bring up is planning. Could you tell us a little bit, the idea being something like an intention, it's normally sitting inside of a larger system, you might say, of planning. So, so can you maybe tell us a little bit about this idea of a system of planning and, how intentions tend to interact with that?
Of course. So intentions are sometimes seen as the kind of end point of a process of deliberation. We've kind of weighed up the pros and cons and landed on a particular course of action. But there's another sense in which that isn't the real end point. So between forming an intention and actually executing it, it's not as if intentions are kind of sitting patiently to be executed and not having any effect on our minds. When we form an intention, it then acts as an input to any kind of subsequent deliberation or reasoning about what to do that we end up doing. So, if I have some plan to go on holiday next summer, then, well, firstly, at some point between now and next summer, I need to figure out exactly what I'm going, where I'm going to go on holiday. I need to buy some tickets and so on. So those are kinds of means end constraints. So we need to, once we've formed an intention that's a kind of end point, we need to intend some adequate means to that end. So that's one sense in which intentions serve as inputs to planning. But they might also act as a kind of general filter. And this is, a lot of these ideas around planning and also commitment. I'm leaning heavily on the work of Michael Bratman, who's a philosopher of action, who talks about this in detail. But he talks about intentions acting as something like a filter on other intentions, on the forming of other intentions. So again, like the example before, if I form an intention to go for lunch with a friend, then that rules out a whole bunch of other things that would be inconsistent with that intention. So we should, generally speaking, when we have intentions in a system, we should expect that they're going to interact with other intentions, place constraints on other intentions in something like this way. You might talk about kind of horizontal constraints, but also these vertical means end constraints.
Oh, interesting. Okay, yeah. I was thinking if someone had the intention of drinking Amstel Light in Denmark, it would be bizarre if they then also subsequently form the intention of never traveling if they're not in Denmark. So that's like by setting the intention of drinking Amstel Light in Denmark, that kind of constrains what other intentions are rational,
precisely,
given that preceding intention.
Yeah. So part of this is a kind of normative rationality kind of consideration, but it's also somewhat causal, right? So sometimes this gets talked about in terms of a rational pressure. So, not only is it rational to do this, but precisely because it's rational, we tend not to form those kind of inconsistent intentions. Those tend to be the exceptions to the rule.
Oh, that's interesting to think about. It's like some of the causality seems to be hinging on the fact that we have this general system requirement to maintain rationality or something like that. Yeah. Interesting. Okay, great. Yeah, I mean, maybe we could just try to, summarize to some degree here. It's like we've said, intentions. Kind of looking at these 5 marks, these 5 characteristics that are typically associated with intentions, and gone through a few key things. They're not just beliefs about the world, because they're not just about representing how things are. They're often about, or they're generally about guiding action toward creating a certain state. They're also not just desires, because like you said, you can have a desire pulling in multiple directions. I can have the desire to both drink a beer, and on the other hand, I also have the desire not to drink a beer, to, be healthy or something. Whereas intentions, they kind of involve a commitment to a particular course of action. And they're also, intentions are not restricted to the immediate future, like you were saying. And they can be formed with a lot of temporal distance. Something can be more nearby versus further out in terms of what I intend. And they're also not necessarily maximally concrete. The intention just to drink a beer rather than to drink specifically Amstel Light in Denmark, and then what else? And then, they're not just plans. Plans kind of flesh out intentions, but intentions do kind of play a distinctive role when it comes to planning. They kind of settle what is to be pursued, and then you kind of structure, and then that settled, goal sort of ends up structuring how the planning proceeds. So anyway, that's just a little bit of a gloss on the 5 things we just went through. Is there anything else when you want to talk about at this point, just in review, or should we start talking a little bit more about the case studies that?
No, I think that's a nice summary, other than, you might just acknowledge the point that these also might interact in different ways, these different features. They might be interdependent. It might be that, precisely because intentions can be very abstract and need fleshing out, that's the kind of thing that motivates the planning relations that we find between intentions. And likewise, planning is going to require some degree of commitment. We need to kind of commit to one thing or another in order to get going with fleshing out our plans. And many of these richer conditions just presuppose the idea of intentions being directive states as opposed to descriptive states. So these interact in different ways, these features.
Interesting. Awesome. Great. Okay, cool. So now that we have these 5 characteristic marks of intention on the table, we can now talk a little about some case studies that you bring up. So maybe, you could just kind of tell us a little bit about, what role are these case studies, kind of playing in your overall argument? I mean, correct me if I'm wrong, but it seems like the idea is that they kind of provide concrete, empirically grounded candidates for intention-like representations in language models. In other words, we look at these case studies from the literature, and we see researchers talking about certain representations, and you notice that, hey, these representations seem to resemble intentions to some degree. So, at any rate, you wanted to tell us a little bit about, what role these case studies are kind of playing in your overall argument.
That's exactly right. So, I'm looking a little bit through the technical literature that's, ever expanding technical literature that's sometimes called interpretability research, or more narrowly mechanistic interpretability research, which is attempting to understand how language models or any other machine learning model solves some particular task, or understand more about its how it works under the hood, and how what kinds of features it might uncover about the world, what kinds of factors might it be leveraging in arriving at a decision. And these two case studies that I focus on, it's kind of each of them. There's kind of a cluster of papers that have explored this kind of stuff, but in each case, I'm finding, as you say, representations that have at least some superficial resemblance to intentions, and maybe the researchers talk about them in something like those ways, use some words like planning and so on that are kind of adjacent to the idea of an intention or a task-oriented representation. And then I'm trying to look more carefully and see, okay, well, compared with these 5 characteristic features, do they resemble intentions in a deeper way? Is this just a superficial resemblance, or is there genuinely something intention-like in a more robust way about the functional role of these representations that are being posited by these AI researchers?
Perfect. Awesome. And so I guess like the first candidate that we're going to have on the table from this first case study is a function vector. I think that's right. Okay. And so, yeah, let's try to lead up to this idea of a function vector. Basically, function vectors, they were kind of, they were posited, or, maybe you could say discovered in the context of few shot in context learning. And so, so can you maybe just tell us a little bit about, what is, few shot in context learning, and, what were the researchers kind of trying to discover about these models?
So it's a bit of a jargon-filled phrase, few shot in context learning, but maybe it's easiest to see by way of examples. So you may have experimented, the listeners may have experimented themselves with chatbots and language models, and realize that if you give kind of a few examples of the kind of thing you want the language model to do, you often get better results than if you have just asked it to perform a particular task without any preamble. And it turns out that language models are quite good at inferring something about the structure of an example or a task that's demonstrated to it in context, right? Which is just technical term for the prompt that you give the model. So one example might be if I gave you the following sequence of pairs of words. If I said to you, rich, poor, young, old, big, small, and then I gave you the word up, and I asked you to kind of continue the pattern. Could you?
Down.
Yes, very good.
All right.
So
I was on the hot seat. I passed. Okay, sweet.
So what you've done there is you've correctly identified that there's a certain relation, a pattern of relations between each of those the values in each of those pairs, namely that they are antonyms or opposites, that words that mean the opposite to each other. So, and then you've applied that very same relationship to the cue word, in this case, up, and you've generated, right, or you've produced the answer down, which is correct in this context. So there are many in this. I'm focusing in particular on a study by some researchers, Eric Todd and colleagues, but in David Bau's lab. But there's many other researchers who explored this phenomenon. And what they're trying to uncover is how exactly can a language model solve tasks like this? How do they figure out how to produce the correct answer, in this case, an antonym of the word up? So, I mean, maybe we can start to get into the details about what these researchers discovered, but that's the kind of the context that sets up where we arrive at something that, like a candidate for an intention.
Right. So it's like we have a general type of task that the model is capable of doing well. Finding the antonym or completing the pattern. And the question is, how is it managing to do this? And I guess was their answer this key idea of the function vector. The function vector is what perhaps allows the model to succeed in not just like a specific task, like from up to down, but like generally across many tasks that fall under that type of finding the antonym. Anyway, so yeah,
Yep.
but yeah, maybe just tell us, like how would you describe what a function vector is?
Yeah, no, that's exactly right. So, maybe just to kind of give some more context. So you might have a task like finding an antonym. You might also have a task like translating English words to Spanish words, or the implicit relationship might be, mapping countries to their capitals or countries to their currencies and so on. So for each of these tasks, models show, some significant degree of success at solving the tasks. And what the researchers discover, and probably don't need to get into the details of exactly how they extracted these so-called function vectors, but they find representations that seem to play a really important role in mediating success at each of these different kinds of tasks. So for the antonym task, they find a function vector that's playing a really important role in mediating finding the correct antonym for a keyword. And likewise, they find a different function vector for the English to Spanish translation task, and a different one for countries to capitals, and so on. And these representations, not only are they kind of reliably triggered in response to kind of demonstrations of the corresponding tasks, so demonstrations of antonym relationships, but they also play a causal role in then generating an appropriate antonym when given a keyword like up. And one thing that the researchers show is that these representations have that effect quite robustly, so across many different kinds of input prompts. And in fact, they even show that if we extract that function vector and put it into a totally new context where we just give a single keyword without any preamble, we give the word common, and then we inject the function vector as the language model is processing that input common. We inject the antonym function vector. It will then cause the model to produce the word rare. So it will kind of induce this kind of antonym producing behavior. What does any of this got to do with intentions? Well, you might think that at a very coarse-grained level, the way the researchers talk about this is representations of a particular task or of a particular function, a particular kind of behavior, that then triggers that behavior whenever the representation is activated. And that's a little bit like the role that intentions play, right? They're representations of a goal state or of a behavior, of a task, that when we activate them or we trigger them, they produce the corresponding behavior or task and so on. So that's one reason why you might think they're at least a candidate for something like an intention. And then there's a question of how well they map onto these different features that we talked about before.
Yeah, that's really helpful. So it's like, when a function vector is active, it seems they have a kind of directive function because it's causing the model to perform a specific task, and it's kind of general, like translate, not just translate dog to perro, or it's really more general of like, this is it's going to cause the model to perform a task like translate, and so it doesn't seem to be just representing like a belief facts. It seems to have that sort of world to mind direction of fit. And yeah, I wish we could go a lot more into all the nuts and bolts, because when you really go into the nuts and bolts of how these function vectors operate, you really see more and more that resemblance you're talking about. It's not, obviously it's tough in a podcast to go into it because it could seem very superficial what we're saying, but like when you look more into it, there's just certain features of a function vector, like the fact that they're more task level, not as like in terms of specifying like what kind of action to perform, rather than just let's produce a very specific output. And at any rate, and they kind of, I don't know, they guide downstream processing, and they're not just correlated with a certain behavior, but they really seem to cause the model to perform a certain behavior. So at any rate, there's various, and the more you go into the details of how the kind of the technical details, the more plausible this resemblance becomes, I think, right?
That's exactly right. Yeah.
Okay, great. And now let's just shift to the second case study, just so that we also have another candidate on the table. And so, could you just tell us a little bit about case study 2, and just to preview, the candidate that's going to emerge from here is something called an output feature. Is that right?
Yeah, that's right.
And so, just like case study 1 produced the candidate of function vector, case study 2 is going to produce this new candidate of output feature. So, can you tell us a little bit about the second case study you use?
Sure. So, this is some research done by researchers at Anthropic. So Anthropic is one of the big tech companies involved in their case, they are the people behind the chatbot Claude that many people will have interacted with. But they also have kind of quite a big research wing to the organization, and they do a lot of this mechanistic interpretability research, trying to figure out how Claude does the many things that Claude can do. And there are a pair of papers that the research team put out early-ish last year in 2025, looking into, they have very broad scope, these papers, but essentially they're working within this tradition of thinking about language models in terms of features and circuits. So I should maybe say a little bit about what those two terms mean. So feature means something like what philosophers mean by representation, or at least primitive representation might be something like a synonym there. So features are supposed to be the things that a language model leverages to deal with a particular kind of input and generate an appropriate output. And circuits are supposed to be kind of connections between features, or algorithms that compute over features in order to produce that output. So in this particular case study, the researchers used a somewhat sophisticated way of trying to identify features in language models, which involves something called cross-layer transcoders. So again, we get into kind of jargon territory quite quickly, but maybe kind of skimming over the details a little bit, they identify what seem to be candidates for representations of different variables that are activated in different contexts when a language model is solving some task, and that play a particular kind of role in generating outputs. And maybe moving from, features usually get talked about in the context of features of the input. So it might be, something like the fact that a particular input has a positive sentiment expressed in it, or the fact that a particular word refers to, someone who's male as opposed to someone who's female. Or that might be the kind of feature that researchers identify. But I think this is the first paper, at least that I've seen, to introduce this idea of an output feature, which is instead some kind of feature or representation in the model that's directed at generating a particular kind of output as opposed to responding to a particular kind of input.
So they're kind of pushing the model toward a certain output rather than just describing the input that's being given.
Yes.
They promote a certain response from
that's right.
From the model.
Yeah. And then, of course, because they're interested in circuits, there'll be interesting relations between these features or these representations. So you might have input features interacting with output features in a kind of complex circuit or algorithm. But yeah, there's this case of a particular case study that I focus in on that's discussed in one of these two papers, which is discussing poetry writing in Claude. And I think that's a kind of fun thing to think about, is if you give Claude a task like, producing a continuation of a rhyming couplet. If you give it the first line of a poem, like he saw a carrot and had to grab it. This is the example in the paper. You might get a continuation which says, his hunger was like a starving rabbit. So it's kind of quite a cute little poem that Claude produces. And we might wonder how a language model can solve a task like this. When you start to think about it, it's a fairly sophisticated behavior. The model has to produce a sentence that both rhymes, ends on a rhyming word, but also that makes sense given the context of the first sentence. And the research is
semantically coherent.
Yes,
yeah,
exactly. Semantically coherent, also coherent in terms of kind of the rhythm of the sentence and so on. And so what the researchers are interested in figuring out at a high level is distinguishing between two possibilities. So maybe the model is just kind of working in an improvisational kind of way. So in other words, for each word that it generates, it just kind of works on the fly. It doesn't take into account, where it's heading or what it needs to end up doing by the end of the second line. And it's just generating token by token off the cuff. Alternatively, it might be doing something more sophisticated, a kind of planning, which involves, electing or landing on an end word ahead of time, and then kind of working backwards from there, writing towards this planned endpoint. And now we can maybe begin to get a hint of where intention-like features might come into the picture. But in short, they present evidence that they think supports this latter hypothesis, that there's something like a planning behavior going on here. And maybe I can talk about exactly what they find there. So what they find in this case of this particular poem, he saw a carrot and had to grab it. That's the prompt that's given to the model. At the end of that prompt, before the model has started generating any words on the second line, the model seems to activate a representation of rabbit. So it's activating a rabbit representation, specifically an output feature in the terminology of these researchers. And moreover, that output feature not only is generated ahead of time, long before it reaches the end of the second line, but it seems to play a causal role both in driving the ultimate generation of that end word rabbit and also guiding or shaping the generation of those intermediate tokens. So the words he saw, his hunger was like a starving. Those also seem to be causally driven by that activating of that rabbit output feature.
Right. So it's so on the one hand, it's kind of it's biasing the model toward a certain output, which is rabbit at the end of that second line. When this feature is activated, rabbit as the final line becomes likely, whereas if that feature is suppressed, rabbit as the final line becomes unlikely. But yeah, like you said, it's not just, and it's important that rabbit feature is active before the second line even begins. So it's not as though the rabbit feature only emerges once it's outputting rabbit as the end of the line. Instead, that rabbit feature is kind of active, prior to even beginning the second line, which, so it has like a kind of future directed sort of orientation there. But then, like you said, there's also that shaping of intervening action. So it's going to constrain what happens in the middle of the sentence. And anyway, so it's like it seems to be writing, as it were, with an end game in mind. At any rate, yeah. Sorry to interrupt.
Yeah, no. That's exactly how the researchers talk about it. And there's then a question of, okay, if we're kind of being a bit more circumspect, how closely does this functional role map onto these 5 features that we've been talking about?
Okay, perfect. And yeah, so now, so we kind of have on the table these 2 candidates that you've extracted from the literature, kind of more technical literature analyzing interpretability literature, I think is what you called it, right?
Mm-hmm.
Okay, so now that we have those on the table, and we kind of have a prima facie case for looking at them, like it's not just we're picking anything to consider whether they satisfy the 5 marks. It's more like, there's a good prima facie case for them, and I wish we could kind of get into that more, of course. But yeah, let's now, I would want to kind of focus maybe on 3 of the marks: directive function, planning, and commitment. But maybe first we could just start with a high level. Do you kind of want to just give the listeners your general overall assessment of to what degree do, on the one hand, function vectors, on the other hand, output features? And it would be nice if we could get in more detail about what's the difference between those 2. But if you want to just give kind of your high level assessment of how intention-like these things are.
I'd be happy to. I think the answer is a slightly disappointing kind of, it's a mixed bag kind of answer, right? So what we don't find, it should be clear, we don't find something that absolutely perfectly matches onto the role of an intention, ticks all of the boxes, and there's no question about it. These are intentions. We also don't find something that's radically unlike an intention, and such that it's completely outrageous that any researcher would ever use a word like intention to refer to one of these features. We end up somewhere kind of uncomfortably in the middle between those 2. So kind of going through the features, we find something like a directive function or some evidence of a directive function for both output features and function vectors. But then there are some questions about that hinge on some technical details, and also some details about exactly what we mean by function and so on. Distality and abstraction, I think the case is fairly strong. We find a range of degrees of distality and abstraction in both cases. But I think there's a question of exactly how distal and exactly how abstract these representations can get. And as you mentioned, you hinted at before, commitment, I think, is probably the place where these models or these representations, candidates for intentions, falter the most. So it seems like there's something interestingly, importantly different from how we think intentions involve commitment in human beings versus how these representations seems to operate, and we can get into that. And planning, I think the case is fairly strong again, although there's some kind of caveats to do with how planning might interact with commitment. So as you can sense from this kind of high level overview, it's a really kind of mixed bag, and I think there is an interesting question about, okay, what do we do with that kind of mixed result? In terms of whether we ultimately treat these as intentions or not, or we just have to sit with the possibility that they're an edge case that's kind of irreducibly an edge case, at least for now, at least in the current generation of systems.
Yeah, and I really think it's kind of a virtue of the paper, kind of the way in which you take a sort of nuanced middle position where you're avoiding 2 extremes of language models obviously have intentions or they obviously don't. Instead, you're kind of arguing for this sort of graded mixed profile. They're they're intention-like in certain respects, but importantly, unlike intentions in others. And so, maybe, again, trying to be sensitive to time here, but maybe we can just talk about some of the bottom line when it comes to each of those 3 marks that I mentioned: directive function, planning, and commitment. And in my sense with the directive function is that, you would want to say that, okay, and it gets into some tricky technical stuff related to prompt processing versus token generation. But would you be able to talk a little bit about, the bottom line? I think it's kind of like, they have a local directive function, but maybe not globally directive. I don't know if that's what you want to focus on here, but what would you want to say about that?
So very quickly, on the positive side, we've already kind of touched on this a little bit, that both output features and function vectors seem to be playing something like this causal role, where when they're triggered, it produces a certain kind of task or behavior to be generated by the model. So that's something like the role we would expect from a directive representation. So that's, a tick in favor of directive function. Where it gets complicated, there are kind of two ways in which it gets complicated. One is to do with how we think about function in philosophy, the definition of a function. There's one rather minimal definition, which is just something like a causal role in producing some behavior of a broader system. And that's the kind of evidence that I was just talking about before. It seems to be, both of these representations seem to be playing something like the role of generating a certain kind of behavior or achieving a certain type of goal. The richer sense of function, which sometimes gets invoked, it should be said, in defining directive function, something like a proper function, which in some people's minds at least is importantly related to the history of a system and the way something was, whether a certain behavior or effect was selected for. So think of the heart pumping blood. It has that function not just merely in the sense that it plays the causal role of pumping blood in the system, but that it's kind of supposed to do that because, one story for why it's supposed to do that is because it doing that in the kind of evolutionary history of the organism was beneficial, and therefore that's why we have systems that have hearts that pump blood today. Where that creates a complication for language models is then we have to think about, okay, these different kinds of representations, how did they arise in the first place? Did they arise through different kinds of training procedures? And some training procedures might involve generating text, but others might not, right? If you think of the mere next token prediction task, then the model is not really generating text in that kind of situation. It's just trying to predict the actual next token in a kind of example sequence. So that creates a potential complication that maybe these causal roles that a directive may have been not explicitly selected for, but they're just a kind of convenient side effect of some behavior that was kind of useful for predicting next tokens. So it gets complicated there. So you might end up with a kind of divide and conquer result there, where some language models have directive proper functions, whereas others just have directive functions that are mere causal role functions, but not really proper functions. That's some of the details. And then you mentioned this distinction between prompt processing and token generation, and maybe we don't need to get into all the details there, but it's there's a situation where we might have different stages in a language model's dealing with a prompt and then generating tokens. So first, if you give a long wall of text to ChatGPT and then click enter, it has to process all that text before it starts generating tokens. So it doesn't start generating tokens after the very first word in your prompt. It waits till the end of the prompt and it's processed all those tokens leading up to the end before it starts generating. And then there's a question of, okay, well, if we find function vectors or output features that are activated during prompt processing before tokens are being generated, then there's a question of whether they're even playing the causal role of a directive representation, because in that phase they're not even being used to generate tokens at all. They're just being used in some way to shape the kind of internal states of the model.
So they're kind of playing more of a descriptive function rather than this.
Potentially. So it may be that it's kind of contextual to some extent whether a function vector or an output feature is playing a descriptive or directive role. That context being the the stage of processing that the model is in. So that was all very quick and high level, but it gives you a sense of how this initial picture of, these seem to be playing a directive role, maybe gets a bit complicated when we think about the details.
Sure. And yeah, so now moving on to that other feature you might want to discuss a little bit, planning. So, we kind of discussed, there looks like there's evidence for planning in the poetry case, like representing future outputs like rabbit, and they're active, several tokens before actually executing, that token rabbit, and they constrain intermediate word choice. And but yeah, what are some of the qualifications that we should think about with respect to planning?
Yeah, so I think the evidence for planning is strongest in the second case study when we're thinking about these output features, and simply because the first line of research into function vectors wasn't looking at this kind of relation between different kinds of representations. But in any case, in this poetry writing example, as we mentioned before, we get representations of ultimate end words that are activated ahead of time, many tokens prior in the sequence, and also they play this kind of dual constraining role, firstly in kind of constraining the words that are generated on the way to ending up with that end word rabbit, but also kind of playing a causal role in generating the token rabbit itself. We might also see something like means-end constraints that we mentioned before. So, for instance, they find a circuit where, or they present evidence, which they suggest is a circuit where, let's say, there's a feature which is produce a rhyming word, produce a word that rhymes with it, and that has a kind of positive activating effect on the feature for rabbit, but also on some other features like grab it and habit and so on. So that might be something like a means-end constraint or causal relationship, that a representation of a certain kind of end is triggering representations of appropriate means to that end, and then ultimately, the behavior that the model lands on, which is generating rabbit. So that's some evidence in favor of planning. So in that case, I think this is one of the surprising and interesting things about this line of research, is that there is something sophisticated going on in terms of mutual constraints among these output-oriented representations in the models.
Excellent. And now turning to commitment, it seems like this is sort of maybe the weakest point when it comes to establishing a resemblance. It's where, I guess, function vectors and output features least resemble human intentions, at least, And maybe to kind of hit on one point that seems kind of important is that it seems like, okay, models, they do bias outcomes, but they don't really commit to outcomes. So maybe that's something we could hit on here. It's just, what's the difference there between biasing an outcome and actually committing to a particular outcome?
That's exactly right. Yeah. So what we see in the case of this poetry example is when we reach the end of that first line, when we have he saw a carrot and had to grab it, not only is a representation of rabbit generated at the end of that first line, but also a representation or representations, features, output features relating to other candidate end words. So you get something like a representation of grab it and habit. And these are all kind of active in parallel. And not only are they active in parallel, they all seem to be kind of exerting some kind of causal influence on the generation of tokens, intermediate tokens, and also that ultimate end word. And one of the ways that we see this is that, at the very end, token, because these models are stochastic, they're not kind of producing exactly the same response every single time. What they produce ultimately is a kind of distribution over possible end words, and then a kind of stage of the architecture then has to sample from that distribution. And of course, if it has a very strong peak around a certain token or word like rabbit, then it'll be very, very likely to end its outputs on that. But it won't be 100% guaranteed. So if we run the model 10 times, we might find that 7 out of 10 times it ends the poem with rabbit. But 8 on the 8th and 9th time, it might end it on something like grab it or habit or something like this. So why is this relevant to commitment? Well, remember before we said that commitment is about electing or settling on one of a range of alternative possibilities and kind of foreclosing or ruling out the question of pursuing the other possibilities. And that means that intentions tend to be fairly mutually consistent. We don't simultaneously intend to go on holiday to Denmark and Thailand and the USA all on the same holiday at the same point in time, because that's mutually inconsistent. We might desire to go to all of those places, but intentions are supposed to be playing this commitment role of electing for one or the other. What we see here is multiple possibilities being entertained, as it were, or active in the model at once. So it's possible that maybe if we keep on looking, we'll find some other representation in the model that is playing something more like this commitment role, actually kind of settling among these possibilities. But I think it might be just a bit of a deeper problem like that these architectures, because they're always activating multiple features at any given time, they're very often going to be operating in more of a way of biasing the model's behavior one way or another, because that's kind of good enough for the task that the models need to solve. And this might be one way in which human intention and practical reasoning differs from these kinds of representations we find in language models, at least in the current generation.
Yeah, it's really fascinating. I mean, it just seems like sampling is really like a crucial thing, because it seems to be explaining why these models fail to exhibit commitment, even though there's like a planning like representation going on and sampling. Because planning without commitment, it seems possible in virtue of that sampling, which sort of has indeterminacy about it, I guess, potentially. But great. Well, that's really appreciate you going through those three there, and obviously, there's so many really rich and fascinating details in your paper, and I wish we could talk more about them. But yeah, obviously, I'm just going to recommend to the listeners that your paper. It's really fantastic in terms of like I mentioned earlier, the nuanced middle position that you've come up with, the integration of empirical and philosophical research, and then also just the conceptual rigor of it. You're not using intention as like a vague thing. It's really you really decompose it nicely into these 5 features. Anyway. Again, highly recommend to the listeners this paper. And at this point, I kind of want to just ask, you want to tell us a little bit about, what you're up to now, what you're working on,
So I'm still thinking a lot about language models and AI systems more generally. And I suppose if you could characterize my kind of general thread of inquiry at the moment, it's these questions about how similar the inner workings of a language model and other AI systems are to the kind of cognition that goes on in human and other animal minds. So one question I'm thinking about at the moment, which is something I've written on in the past, is more fundamental questions about representation in AI systems. So Do we have good evidence to say that a model really is representing a particular feature of our world, especially if it's a system that's only ever been trained on text? It hasn't ever directly interacted with our world. And many people have argued that you need to know something about the history of a model to answer some of these questions. It relates to a bit what we were talking about functions. And I'm kind of trying to scrutinize this assumption a little bit. Do we need to know something about the history of a system, its etiology, in order to know what kinds of things it can represent or it does represent? So that's one project I'm working on at the moment. But stay tuned. And maybe I should just say, for kind of full transparency, this paper we've been discussing is still under review. So this is a preprint at this stage. But hopefully it'll be. You can find it as a preprint online on Phil Papers, but hopefully soon will be a slightly more refined version of the paper in print somewhere.
Awesome. Well, thanks again so much for coming on, Iwan. Appreciate it.
Thanks so much, Sam.